Hello, dear students. Welcome you all in my channel. So today we discussed about Kirchhoff's current law and perform experiment on Kirchhoff's current law. As you see on your computer screen, we designed this type of circuit on our Tinkercad, right? So before designing the circuit, we must know about some basic concepts about the Kirchhoff's current law. As we know that Kirchhoff's current law is it is the algebraic sum of current meeting at a closed closed circuit is equal to 0. So in Kirchhoff's current law, the incoming current towards the node is taken as positive, and while the outgoing current is taken as negative. So before starting the circuit, we must know about how many nodes in the circuit. So as we know that what is node? Node is a point in the circuit or network where two or more than two circuit elements are joined. So in this circuit, we have, according to this definition, we have 1, 2, 3, and 4. So total number of nodes in the circuit we have 4. And how many loops in the circuit? And as according to definition, loop is a closed network which may be further divided. So according to this definition, in this network we have three loops. So A, B, E, F, A, this is loop number first, and B, C, D, E, B, this is loop number second, and A, B, C, D, E, F, A, this is loop number third. So mesh is a point where mesh is a closed network. It is a closed path and it is a most elementary form of loop which may not be further divided. So mesh is a most elementary form of loop which may not be further divided. This is named as loop. So in this network we have two loops, two mesh, A, B, E, F, A. This is mesh number first, and B, C, D, E, B. This is mesh number second. So third point, next point is active element. So active element, what is active element? Active element are those elements which give supply to the circuit. So as in this network, we have active element is battery. And what is passive element? Passive element are those elements which receives energy from the active element. So in this network, we have passive element is R1, R2, R3, and R4 means resistances. So what is the main objective of this experiment? The main objective of this experiment is to measure the current across each and every resistances. So as we know that in the uh, series connection, current is always remains same. So that's why ammeter is connected in resistance R1, R2, R3, and R4, and with the help of this ammeter, we measure the current across resistance R1, R2, R3, and R4. So as this is a parallel circuit, so we design this circuit onto the Tinkercad software and find out the current across each and every resistor, right? So we start our designing part. As you see in the Google, and onto the Google search bar, when you type Tinkercad and press enter, and you get this type of option, Tinkercad create 3D design. And when I click onto this, and a new screen opens, and onto this screen we will find, yes, this type of screen we find. Yes. So into this screen, we have an option of sign in. So when we click onto the sign in, we have a multiple options. So onto the Tinkercad, we always sign in with Google. So when I click onto the sign in with Google, a new window opens, and we will find a window, and yes, into this window we get a option of sign in. So by filling your email ID and password of your Gmail account, you will able to access Tinkercad designing part. So after clicking sign in with Google, we will find a screen in this manner, and when we click onto the circuits, and we get this type of option where we click onto the create new circuit, a green color option, and after clicking on create new circuit, we will get a new screen, right? So onto the right side of the screen you have a multiple components, or we say that is a component library. Okay, so in order to perform the experiment of Kirchhoff's current law, we have a requirement of breadboard, and we have a requirement of resistance, we have a requirement of ammeters. So now we use multimeter to measure the current. Okay, so what is the how to measure the and how to design the circuit? This part uh, we discussed in my previous lab session. So you click, you may type on your YouTube Vasu Electro tutorials, and you will find the designing, how to design onto the breadboard part. So when I type a breadboard onto the search bar, we will find this type of option, and by clicking drag and drop from right side to the left side, we able to move breadboard from right side to the left side of the screen. So as you see, this is our breadboard, and into the breadboard we have a couple of ports, and the upper and the lower slot is horizontally shorted in this manner, and the middle ports is vertically shorted in this manner, right? So when I type over here a resistance, so resistance is already there. So we can choose any value of the resistance. Suppose in order to perform the experiment we always take same value of the resistance, that is in 10 milliohm, so in order to get the accurate result. Similarly, we rotate this resistor with the help of this option. So in this manner we design, we put the resistances in this manner. So now the question arises, why we put these resistance far apart from each other? The answer is in order to connect the uh, multimeter in series with each and every resistor, we connect these resistance in this manner. Okay, so as the circuit, in this circuit, a ammeter is connected in series with resistance R1, A2 is series with resistance R2, and A3 resistance A3 ammeter is connected in series with resistance R3, and A4 is connected in series with resistance R4. So we similar design we make onto the Tinkercad, right? So we type over here first. We take a battery source. We take a battery source and we change the color of this wire with the help of this option. We change the color, and similarly this is our multimeter, and into the multimeter we have a mode option, and in the mode option we have a multiple quantities which we want to measure. So as in the KCL experiment we want to measure the current, so we set amperage, and according to this circuit, as you see here, in this circuit we connect the positive terminal of ammeter to the positive terminal of battery, and negative terminal is connected to the resistance R1. So accordingly we make the connection into Tinkercad. So we connect the, as in the multimeter, the red port is for positive and the black is for negative. So we connect the positive terminal of the multimeter to the positive terminal of a battery. So as in the multimeter also, the negative positive part is red and the black part is negative. So we connect the positive terminal of the multimeter to the battery and negative terminal across the resistance in this manner. And similarly we take second ammeter, and as in this screen we have a resistance R2, and in this resistance R2 we connect the positive terminal of ammeter to the, suppose we first connect the resistance, we first connect ammeter A4 across resistance R4. So we connect the positive terminal of ammeter to the negative terminal of the resistance R1. So we connect the positive terminal of ammeter to the negative terminal of resistance, and connect the negative part across this resistance. So as this is our ammeter 4, now we connect the ammeter A2, we connect A2 ammeter A2, and into that ammeter A2, as you see here, just a minute, what we did in A2, in ammeter A2 we connect the positive terminal of ammeter A2 to the positive terminal of or say positive terminal of ammeter A2, or say negative terminal of resistance R1, right? So this is the negative terminal of resistance R1, and now the connection for the second resistor is complete. This we write over here ammeter A2, and this one is our resistor ammeter 4. And what we did in A4 as sorry, A3, this is our resistance, this is our ammeter A3. In A3 we connect the positive terminal of ammeter A3 to the negative terminal of resistance R2. This is our A3. So we connect the negative negative terminal of ammeter to the negative terminal of resistance, and so in this manner our connection for the KCL circuit is complete, and now we going to start simulation to find out the result. So as you see on your computer screen, we will find the result 5.93, 3.96, 1.98 and 1.98. So now the question arises, how we prove that Kirchhoff's law is verified. So as you see here, just a minute, as you see here in the screen, we have as you see here, suppose we have resistance, we have 4 resistance, and a battery source is connected. This battery is V1. This is the resistance R1, R2, R3 and R4. So the current measured by this I1, this is I2, this is I3, and this is our I4. So we know that if we have current I1 is equal to I2 plus I4, if current I1 is equal to I2 plus I4, and the second equation is I4 is equal to I2 plus I3. So if we verify these two equations for the Kirchhoff's current law, then we verify Kirchhoff's current law. So as we verify from this equation, we verify Kirchhoff's current law, because this is our resistance R1, R2, R3 and R4. So according to this equation, we will find our uh, answer, and we verify Kirchhoff's current law. So I think your concept for the Kirchhoff's current law is clear. So thank you very much for listening me, and please like, share and subscribe my channel if you satisfied this PPT. So thank you very much for listening me. Have a nice day.